right, well, let's go over the answers to the density problems worksheet. So there was 4 questions on this one. The very first one said, a gold-colored rock has a mass of 36.2 grams and a volume of 278 milliliters. Is it gold if the density of the gold is 19.3? So what you needed to do was you needed to use density equals mass over volume. So when you put in the mass is 36.2 grams, and the volume is 278 grams. I'm sorry, milliliters. Now what you have to do is utilize your calculator that's on your computer, which is in the bottom left-hand corner, and you type that in. And if you type that in and divide it out, then you're going to end up with the density equals 0.130 grams per milliliter. So is this gold if gold's density is 19.3? No, it's not even close. All right, it's definitely not gold. Looks like it's fool's gold, all right, which there is actually a substance called fool's gold, which looks like gold, but doesn't have the density of gold. So that would be the answer for that one. All right, we go on to the next one. Number two says we're supposed to find the density for these washers. And we have, starting with 10 washers, and with the 10 washers, we have a mass of 24.1 grams, and we have a volume of 3.35 milliliters. And we've got to divide that out and find out what's the density if I had 10 of these washers based on this data. And if you did that, you should have gotten 7.19 grams per milliliter. Now if we do 20 washers, in 20 washers we're going to, we were given that we've got 48.3 grams, and we have 6.65 milliliters. If you divide that one out, you get 7.26 grams per milliliter as the answer. That's interesting. Seems like when we would have gone from 10 and we would have doubled our number of washers, doesn't it seem like the density would have gone up? Like maybe even doubled? So like double 7 would have been like 14 grams per milliliter? But if you remember in the notes, we talked about the notes and said that it doesn't matter whether I have a whole truckload of gold or I have a little chain link of gold. The density of the gold doesn't change because we're always comparing it back to 1 milliliter. That's why the bottom piece of this is a milliliter. It's really 1 milliliter. So we're always looking at what's the mass of 1 milliliter based on this information. So with that in mind, if we go to the 50 washers, we've got 120.1 grams. And that's actually got a volume of 16.65 milliliters. If you divide that out, you should have gotten 7.21 grams per milliliter. So looking at those, we want 7.19 and 7.26 to 7.21. We can basically say that the density didn't change. It's pretty close to the same, right? It's really all basically about 7.2 all the way down. All right, so it doesn't matter. If we had 1,000 washers, it would still be about 7.2 because we're always comparing it back to 1 milliliter. And that again is why we have that milliliter on the bottom. It's really just over 1 milliliter. All right, so that was question number 2. Now let's go to question number 3. And question number 3 says, question number 3, a silver necklace has a mass of 11.1 grams and a volume of 75.2 milliliters. Is this necklace pure silver if the density of pure silver is 10.49 grams per milliliter? So we're going density equals mass over volume again. We've got a mass of 11.1 grams. And our volume is 75.2 milliliters. So we divide that out using the calculator again, and we get a density of 0.147 grams per milliliter. Is that silver? No, looks like you got tricked again. It's not silver, it's some sort of fake silver. So it's not silver. It's like the idea of the fool's gold. This would be fool's silver, I guess. I don't even know if there is one. But, so this is not silver. All right. Now the last piece, I hope one of you or some of you actually tried the idea of trying to float a cup in water like in your sink and see if you could get it really, really, really low by filling it up with some sort of sand or dirt. And if you got it really, really low, so that what I'm talking about really, really low is that here's the top of the water, right? What you wanted to be able to do is make it so that the cup actually floated like this. So it was like way down in the water. You don't want it to float like this. If it floats like that, then that means it's way less dense than water. And the density of the water is 1 gram per milliliter. That's what water's density is. So this cup right here, that's floating almost just to the point where it's just about ready to go and sink all the way to the bottom, this thing actually has just about 1 gram per milliliter. It's almost exactly the same as the water, and that's why it floats so low. This guy up here is probably more like 0.2 grams per milliliter, and that's why it's floating so high. Right? So if we were to drop a rock in there that maybe had a density of 5 grams per milliliter, where is it going to go? Right down there. A rock with 5 grams per milliliter is going to sink. Right? And that's what I wanted you to get from that last question, is that we're trying to make this cup so it has exactly the same, or really close to the same density as water, so it floats as low as possible by adding more mass to it. The volume you couldn't change. The cup was going to be the same size. But you could change the mass by adding stuff to it. So now that we've talked about it, maybe you want to go home and try it if you didn't get a chance to. You can try it in your kitchen sink or your bathroom sink and see if you can get it to float lower. It's also why, have you ever noticed when you go swimming, how you like sit there and kind of like bob around the water? Because what are you mostly made out of? Water. So you have a density, or basically your density of the water that's in you is 1 gram per milliliter, just like the water that you're floating in if you're in a pool. So you're going to float very, very low in the water. Right? You're not going to sit up on top of the water. You're not going to sink all the way to the bottom. You're kind of going to float. Right? So, all right, with that, that's the end of these notes. See ya.